Lesson 1.3.1 Linear Regressions. Determining linear regression equations and correlation coefficients for data sets. Correlation vocabulary. Correlation coefficient. Correlation coefficient is a value between -1 and 1, which indicates how close the data are to the graph of a regression equation, If it falls between -1 and 0, the data shows a negative association, or between 0 and 1, the data shows a positive association. The stronger the relationship is between two variables, the closer the value is to 1 or -1. The correlation coefficient is also called the R value. And we'll talk about that more when we get into doing the problems. So at this point, you probably want to pause it so you can go ahead and copy this down. Number 1. Determine the linear regression equation and correlation coefficient for each data set. Circle which of the linear regression equation is appropriate for the data set. Circle whether the linear regression equation is appropriate for the data set. Round your answers to the nearest whole number. Make sure when you're doing these problems that you read directions carefully. Number 1 says the table shows the attendance for the varsity football game at Pedro's High School. And we can see game 1. Change my pen color. Game 1, there was 2,000 people. Game 2, there was 2,132. Game 3 had 2,198, and so on and so forth. So we are going to use this table to find an equation. So in order to do that, we need to go ahead and go to Desmos. So if you don't have Desmos up, you should pause the video here and load Desmos right now. So in Desmos, the first thing we're going to need to do is click on the plus in the upper left-hand corner. So we're going to click on the plus over here in the upper left-hand corner. And then we're going to go down to Table. I'm going to go ahead and click on Table. Okay, and then we're going to go ahead and type in the values from the problem. So the x values are 1, 2, 3, 4, 5, and I think 6. Let's go ahead and check. 1 through 6. That's good. And then we need 2,000. So we're going to need 2,000. 21, 32, 21, 98. So at this point, if you haven't typed the stuff in, go ahead and pause the video so you can get caught up by putting your table in and adding the values. So the next thing we're going to do is we're going to go to line 2 and we're going to write in the regression equation for Desmos. which is going to be y sub 1 tilde a x sub 1 plus b. So we can go ahead and type y, and then you can hold shift and the minus button, and that'll give you lower your, or let you do the subscript on here. Okay, you can also come down to the keyboard and click on ABC, and then there's a, right next to the 1, 2, 3 on the bottom there is an A sub B, and that lets you go ahead and put a subscript as well. Then you're going to arrow to the right so that your cursor's big again, and then on your keyboard just above the tab button you can hold shift and push that button, or on the keyboard for Desmos there's a little tilde right here and you can click on that. Then we have to type A X, and again we're going to put that little subscript, so I'm going to click the A sub B or hold shift and the negative key, type 1, arrow to the right and go plus B. And then from there it automatically goes ahead and calculates the information we need. So you can see here we have our R value that I talked about, the correlation coefficient. Down here it tells us what A is, and here it tells us what B is. So we're going to use this information and we're going to write our equation. So let me slide this over here out of the way so I can use it. And so where it says linear regression equation, I'm going to go ahead and write y equals, and I'm going to round my A value to the nearest whole number. So it's going to be 73. And then after A is x, and then we go plus, and my B value is 1963. And again, I get it from over here on the Desmos part. Okay, 1963 we have to round up because of the 8. And then our correlation coefficient, I'm going to pause it. I want you to answer this question. What is the correlation coefficient? So our correlation coefficient is 0. And you can go 2 decimal places with this. So 97. That should be enough information to tell us whether the graph is a good fit for the data or not. So now we're going to circle one of these 2 things here. Okay, and the way we determine this is the closer this R value is to 1, the better the fit is. And so since this R value is close to 1, and I would say anything 0.7 or higher, 70% or higher, would be classified as a good fit for the data. So since this is 97, it is clearly a good fit for the data. So we're going to circle that. And now we're going to go ahead and predict the attendance for the graph for game 9. So you can see that we are taking f of 9 in order to do this, which means that in our equation up here, we're going to replace the x with 9. So I'm going to have y equals 73 times 9 plus 1963. So now that you found the 73 times 9, I'll show you. You could also continue using Desmos over here and just continue to type 73 times 9, and it gives us a value of 657. Plus 1963. And then we can actually continue in Desmos and just type 9 plus 1963. And here's our final answer, 2,620. And it says, make a prediction. So in order to do that, I'm going to minimize Desmos so that I can see the original problem. And so then we would say the attendance in Game 9 will be about 2,620 people. The reason we use the word about is, again, it's a prediction. Okay? It's not a fact. The game hasn't happened, so we don't know the actual value. So it's our prediction, and so we have to use the word about. Number 2, the table shows the attendance for the annual spring concert at Eve's High School for 6 years. And so we can see on the table, we have the years over here, we have numbers in the middle, and then we have attendance. So when we are dealing with years, okay, we always convert it into single digits or a number system, not using years themselves. Okay, otherwise our equation doesn't come out very pretty. So we use the single digits in place of it, and we always start off with 0. This is also used when we're talking about months. Okay, we use the same idea with the problems that have a month listed as well. Okay, so we're going to always turn it into a table with numbers. And so when we go to use Desmos, we're going to use this portion. Okay, and then later we have to translate years back into, or the numbers back into years. But we'll talk about that when we get closer to it. Alright, so what I want to happen right now is that you go ahead and try this problem on your own. You need to go ahead and pull Desmos back up. Okay, you're going to use Desmos. Oh. And you're going to replace the values in the table with the new values. Notice we have 1, 2, so we're going to have to go back and replace 1 through 6, and we're going to have to replace 2,000 and so on and so forth. And you can get rid of line 3. When you do that, the Desmos is automatically going to calculate your new values on part 2, so you don't even have to redo that part. So go ahead and do this now. Okay, so we change our values in Desmos. Replace the old values with the new ones here. And like I said, the calculator on line 2 will automatically find the equation for you. And so then we took our A value, which we rounded to 25 because this is a 1, and we took our B value, which rounded to 771 because this is a 2, and we wrote our new equation, y equals 25x plus 771. The correlation coefficient was 0.88. Ooh, epic fail, Mr. Sneed. .89. Mr. Steen doesn't know how to round apparently. He fixed it though. 0.89. And then we go ahead, and this is a good fit for the data because this is close to 1. Again, I told you as long as it's higher than 70, I would say it's a good fit for the data. And then in 2017, so we have to look at this a little more carefully. I mean, I gave you 10, but I didn't say why it's 10. If we look at 2012, okay, that was number 5. 2013 is 6. 2014 is 7. 2015 is 8. 2016 would be 9. And 2017 is going to be 10. So we had to look past and count out till we found out the year 2017 to figure out what number to use. Okay. If you need to write it out, write it out. If you can count it out, count it out. Okay. But you just need to figure it out. The other thing you could have done is we're looking at 2017. You can subtract the starting year of 2007 from it, right? The 7s subtract, you get 0. 1 minus 0 is 1. And then these all cancel. And so then that's the other way you can get the number without having to count out the rest. Okay, that works with the years because we start at 0. All right, and then we plug in 10. We do 25 times 10, which is 250. We add 250 and 771, and I had used the calculator for that, right? And you can use Desmos for all of your multiplying and adding. And I got 1021. And then the prediction in the year 2017, the attendance will be about 1,021 people. And with that, that's how we do linear regression equations.